we're going to cover section 1 today with our greatest common factors in our grouping. We'll do section 2 over 2 days, Wednesday, Thursday. We'll cover our special case factoring on Friday. We're going to skip section 4, and we'll do our solving equations next week. Okay, that's how chapter 6 is going to work. So to start, again, understanding very fundamentally what factoring is. Factoring is undoing multiplication. It's essentially division, except we just don't necessarily know what we're dividing on. The exception to that is greatest common factor, because we will divide by the greatest common factor. But you need to understand that factoring undoes, or is the reverse of, multiplying polynomials. Okay? We're undoing that multiplication. Now, from now until forever, whenever you're factoring, your very first step needs to be checking whether or not you have a greatest common factor. Okay? Beyond today, most of the time you won't have a greatest common factor. But the one time you miss it is going to throw off the whole thing. You always need to check for a GCF first whenever you are factoring. Always, always, always. And there are certain cases where if you forget to do that and you try and factor, you may be missing important information. You may be leaving something out that you need to make sure that you still have. Our greatest common factor is the largest term that is a factor in all the terms. Again, mathematicians, we're not clever. We name things for what they are. A greatest common factor is the largest that they have in common among factors. Now we're going to break it down real simple, but you're going to get pretty proficient pretty quickly. But you really need to understand at its very core what's happening here. Okay? I have the term 7k, which is 7 times k. 7 and k are factors of that term. Factors means we're multiplying. Okay? 7 times k. What factors or what things can I multiply that gives me 28? And 4. Okay? There's other factors. 2 and 14, 1 and 28. We have lots of different factors we can choose from. We're specifically going to choose 7 times 4 because we're looking for a common factor. What is the common factor between those two terms? 7. So both of those terms are being multiplied 7. We're going to undo that multiplication by factoring out that 7. And when I divide both of those terms by 7 to do that factoring, I'm left with k plus 4. Okay, so at its core, that's what we're doing. We're identifying what a common factor is. We're dividing both terms by that factor to reduce them, and then we write that common factor on the outside. Okay? There are some expressions that will have multiple common factors. Again, we want to find the greatest. When I look at 32 and 24, 2 is a common factor, 4 is a common factor, but are they the greatest common factor? No. What is? 8. So we want to find the greatest common factor among both of those. So again, we identify that it's 8. I can divide both of those by 8, and what am I left with? 4n plus 3. Okay? What about for C? Okay? 1 is always a common factor. Now, if I factor out a 1, is that going to change my impression at all? No. But sometimes it'll be necessary to not factor out a 1, but instead to factor out a negative 1. 1 is always a factor. Negative 1 is also a factor. It's not going to help us simplify this anymore, but if I did want to factor out a negative 1, if I divide both those terms by negative 1, what do I end up with? Switches those signs. So, understanding that equivalency is going to be useful. There will be times where we need to factor out a negative 1. Most of the time we won't have to bother. But there will be times where we need to factor out that negative 1 for whatever the situation calls. So always keep that in mind. -1 is always a factor. 1 is always a factor. Okay? 1 and -1. Both of those are factors. And a lot of times we'll use those when we're doing factor by grouping. We'll use 1 or -1. That's where it shows. All right? What about for D? What's my GCF? 5. I can divide both of those by 5, and what am I left with? Z plus 1. That plus 1 gets left off a lot. A lot of people will say, oh, okay, let's divide both of those by 5. Oh, that cancels out, and they just make it go away. It simplifies to a 1. If you start with 2 terms, you need to end with 2 terms. Start with 2 terms, end with 2 terms. 2 terms, 2 terms, 2 terms, 2 terms. So when you're factoring, however many terms you started with, none of them are going to go away. You'll still have them. Now it may be a 1 or a -1, but you still need to keep that term. Now for E, I've got 3 terms. So my factor should have 3 terms. My GCF doesn't just have to be numerical, it can be algebraic as well. Let's focus on the numerical part. If I've got 150 and 25, what's the greatest common factor of those 3 numbers? 25. Then we look at our variables. Variables are really easy because variables will be the lowest exponent of all of that variable. So I have an exponent of 5, 4, and 3. Our GCF is going to be the lowest one, m to the 3rd. So if I factor out m to the 3rd from 100m to the 5th, what am I left with? 4m squared. Then my next term. 2 what? M. And then my last term? 1. I started with 3 terms. I have to end with 3 terms. That last one just simplifies to 1. GCF for F. Look at the numerical part. What's the numerical GCF? There you go. Lowest exponent on m is 4. Lowest exponent on x is 3. So my GCF is 4m. I'm sorry, 5m to the 4th, x to the 3rd. So what's that first term? Second term. Mx to the 3rd. And the last one? Okay, that m to the 4th will cancel on that last term. So we're just left with x to the 3rd. Okay, so those are all monomial greatest common factors. But greatest common factors don't just have to be monomials. They can be polynomials themselves. So I have a plus 2 times a minus 3 plus a plus 2 times a plus 6. Each of these are a term. The factors in each of these terms are a plus 2 and a minus 3, a plus 2 and a plus 6. So what factor do they have in common? A plus. It's that entire binomial. Factor, factor to make a term. So this has 2 factors of a plus 2 and a minus 3. A factor and a factor multiplied to make a term. So they have a common factor of a plus 2. So I can factor out a plus 2. If I take away the a plus 2, what am I left with in the first term? A minus 3. That whole binomial is left. Put this in a bracket. A minus 3 is left. What am I left with in the other term? A plus 6. And now that all my multiplication's gone, all I have is a distant subtraction. I can drop those parentheses. And now that those parentheses are gone, what can I do now? A minus 3 plus a plus 6. Yeah, combine your like terms. Then we can go ahead and combine our like terms. Now it's factored. What's my greatest common factor for b? Y minus 1. So factor out y minus 1 and then look at what we have left. But be very, very careful. What's the notable difference between that and that? That's going to change our process slightly. Negative. That subtraction sign in the middle. What do I have to do with that subtraction sign? Distribute it. You're going to distribute it before you combine like terms. So we have y minus 1 times y plus 3 minus y minus 4. Simplifies to what? Y minus 1 times what? Combine like terms. Got to add. Negative 1. Y minus y is 0. 3 minus 4 is negative 1. If we wanted to, we could distribute that negative 1 back in. Gives us an equivalent expression of negative y plus 1. So I hinted at this. Sometimes there's a couple different ways to factor. What's one way that I could factor negative 6r squared plus 5r? Negative r, and what else? Positive r. Depending on the need, I could either do a positive r or a negative r. I can factor out a negative r. If I factor out a negative r, what does that give me? What am I left with inside? Okay? Or I could factor out a positive r, leaving me with so sometimes we'll need that negative. It just depends on the situation. But be aware that the negative is always an option. If we need to change the signs of the terms for any reason, usually because of factor by grouping, then that negative can help us in that process. Okay? Negative factors are always there. So sometimes all the terms in a polynomial have a common factor of 1. That's it. And so we can't factor it a GCF among all of them. But we still can possibly factor it by using factor by grouping. And so that's where we look at half of the expression and see if each half has its own common factor. Now, normally when we're factoring by grouping, we're dealing with polynomials that have more than 3 terms. That's when we would need to do that. Okay? And so for our case, we're going to be dealing with polynomials that have 4 terms. So when I look at my first polynomial, I have 6p and 6q and rp and rq. None of those have a common factor among all of them other than 1. So it doesn't really help me any. I could factor out a negative 1, but all that's going to do is change my signs. So we factor by grouping. We group the left half and the right half together. And then we check for a greatest common factor among each of those. What is my GCF for the first 2 terms? 6. What am I left with? Now, when we're factoring the right half, we want to make sure that we end up with p minus q. So we have to ask ourselves, what can I factor out that will leave me with that same binomial p minus q? R. Is it a positive r or a negative r? Positive, so we'll put that plus. That positive r plus r. And so now, what we have here is a term and another term that have a common factor. What do they have in common? P minus 2 terms, a common factor of p minus q, so we can now factor out p minus q. What am I left with when I factor p minus q out of the first term? And then out of the second term, we're left with the positive r. So we're forcing a common factor out of 4 terms by doing that grouping. When I look at the one underneath that, xy minus 2y minus 4x plus 8. What's my GCF for my first two terms? Y. What am I left with? Minus 2. So we factor out y, we're left with x minus 2. Now on the right side, I want to end with x minus 2. So what do I factor out so that I end with x minus 2? 4. It has to be negative, so that 8 changes to a negative 2. If I just factor out a 4, it's not going to change the sign. I need it to be identical. So we factor out a negative 4. So then what are my final two factors?
1 minus 4 and then x. Is this grouping?
Top right, GCF. On the left. N leaves me with what? And then what can I do on the right to still end with k plus m? Negative. That's where that negative 1 comes in handy. Negative 1's always a factor. I had k and m, they were just the wrong sign. So factoring by negative 1 takes that out. N minus 1 and k plus m. This last one, GCF on the left. Okay, what does that leave me with? X squared, y squared minus 9. What can I factor out on the right that gives me 5x squared, y squared minus 9? Nothing. So, rearrange it. Commutative property of addition. I can add those terms in whatever order I want, which means I can rearrange those terms in an order that makes grouping possible. When you've got multiple variables, and a lot of times you've got two variables in one term, you need to make sure that the term next to it also has a variable so that you can factor that out. So what I'm going to do is I'm going to take these two and I'm going to switch them. And it may be a little trial and error. There's a couple different options. You could switch the 15 and the 18 and put the 18 at the end. There's a couple different ways you can rearrange it. But what you need to do is one of these two terms has to be paired with the 10x squared y squared. Okay? So I'm just going to swap those two. 10x squared y squared minus 12x squared plus 15y squared minus 18. And then I'm going to do my group. Now what's my new GCF for the left side? 2x squared. Leaves me with 5y squared minus 6. And then on the right, so that I end with 5y squared minus 6, what do we factor out? Plus 3. 2x squared plus 3, 5y squared minus 6. Those are my factors. Questions, comments, concerns, queries, or? And again, as we move into the rest of the week and we continue factoring, the first thing on your mind always needs to be, is there a GCF? Is there a greatest common factor? If there is, you have to factor it out first, then we'll continue with other methods along that. Okay? All right, your assignment.